Welcome back to JVM Internals Crashcasts. I'm Sheila, and with me as always is the JVM virtuoso, Victor. Today we're diving into an exciting topic in our JVM Languages chapter, language interoperability. Victor, are you ready to explore how different JVM languages can work together in harmony?
Absolutely, Sheila. I'm thrilled to discuss this topic. It's a crucial aspect of modern JVM development that opens up a world of possibilities for developers.
Before we jump in, let's start with a quiz for our listeners. Here's the question. Which popular code hosting platform, written primarily in Ruby, later incorporated Scala for its real-time features? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's an intriguing question, Sheila. It really highlights how even major platforms can benefit from mixing languages. I'm curious to see how many of our listeners can guess this one correctly.
Now, let's set the stage for our discussion. Victor, could you briefly explain what we mean by language interoperability in the context of the JVM?
Certainly, Sheila. Language interoperability on the JVM refers to the ability of different programming languages that target the Java virtual machine to work together seamlessly. This means code written in Java can interact with code written in Kotlin, Scala, Clojure, or any other JVM language, and vice versa.
That sounds powerful. It's like having a United Nations for programming languages, where they all speak a common language, JVM bytecode. Is that a fair analogy?
That's an excellent analogy, Sheila. Just like how diplomats at the UN might speak different languages but can communicate through interpreters, JVM languages can interact through the common interpreter of JVM bytecode. This shared foundation is what makes interoperability possible.
Fascinating. So, how does the JVM actually enable this interoperability? What's the magic behind it?
The key is that all JVM languages compile down to the same bytecode format. This bytecode is what the JVM understands and executes. So, from the JVM's perspective, it doesn't matter if the original code was Java, Kotlin, or Scala. It all looks the same at the bytecode level.
That makes sense. But surely there must be some challenges when different languages try to work together. What are some of the hurdles developers might face?
You're right, Sheila. While the JVM provides a common platform, there are indeed challenges. One significant issue is dealing with different type systems. For example, Scala has a more advanced type system than Java, which can sometimes lead to compatibility issues. Another challenge is handling language-specific features that don't have direct equivalents in other languages.
I see. So it's not all smooth sailing. Can you give us a concrete example of how interoperability might work in practice, maybe between Java and Kotlin?
Absolutely. Let's take Java and Kotlin as an example. Kotlin was designed with Java interoperability in mind, so it works particularly well. You can have a Java class that defines a method and then call that method from Kotlin code with no special syntax. Similarly, you can extend Java classes or implement Java interfaces in Kotlin.
That sounds incredibly useful. I can imagine it would allow teams to gradually adopt Kotlin in their Java projects. Are there any best practices or tools that developers should be aware of when working with multiple JVM languages?
Definitely. One key best practice is to define clear boundaries between different languages in your project. This can help manage complexity and make it easier to reason about interoperability. As for tools, most modern IDEs like IntelliJ IDEA or Eclipse have excellent support for multi-language JVM projects. They can help with navigation, refactoring, and highlighting potential interoperability issues.
That's great advice, Victor. Now, I'm curious about performance. Does using multiple JVM languages in a project impact performance compared to using a single language?
That's an excellent question, Sheila. In general, the performance impact of using multiple JVM languages is minimal. Remember, it all compiles down to the same bytecode. However, there can be some overhead in certain scenarios, particularly when dealing with language-specific features that require runtime support. But for most applications, the difference is negligible, and the benefits of using the right language for the right job often outweigh any small performance costs.
Fascinating stuff, Victor. Before we wrap up, do you have any interesting anecdotes about language interoperability on the JVM?
Actually, I do. There's a famous case study from Twitter. They originally built their backend in Ruby, but as they scaled, they faced performance issues. Instead of rewriting everything in Java, they strategically rewrote performance-critical components in Scala, which runs on the JVM. This allowed them to interoperate with their existing JVM-based services while gaining the performance benefits of Scala. It's a great example of how language interoperability can be used to evolve and optimize systems over time.
That's a brilliant example, Victor. It really showcases the power of JVM language interoperability in real-world, high-stakes environments. Now, let's reveal the answer to our quiz question. The popular code hosting platform that was written primarily in Ruby and later incorporated Scala for its real-time features is GitHub. They used Scala for their real-time features like live updates and notifications.
Great question, Sheila. It perfectly illustrates how even major platforms can leverage the strengths of different languages within the JVM ecosystem.
Absolutely. To wrap up, let's summarize the key points we've covered today. 1. JVM language interoperability allows different JVM languages to work together seamlessly. 2. This is possible because all JVM languages compile to the same bytecode format. 3. While powerful, interoperability comes with challenges like differing type systems and language-specific features. 4. Best practices include defining clear language boundaries and using IDE support for multi-language projects. 5. Performance impact is generally minimal, and the benefits often outweigh any small costs. In our next episode, we'll be exploring performance considerations in JVM languages. Until then, keep exploring the fascinating world of the JVM.
Looking forward to it, Sheila. And to our listeners, if you've enjoyed this deep dive into JVM language interoperability, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue bringing you these in-depth explorations of JVM internals.
Thanks, Victor, and thank you all for listening. See you next time on JVM Internals Crashcasts.